You guys remember? Isosceles triangle, what do you remember? 12, what do you remember? Anything? Isosceles?
It has like two sides.
Yeah, that's what you guys remember. Two sides congruent. All right, I'm going to add on to that now. All right. Not only does an isosceles triangle have two sides congruent, it also has two angles congruent. All right. Where do you find those two angles? Well, honestly, guys, it depends on where the sides are congruent. All right. So you see my example here. I gave you A, B, and AC. So we're all in agreement at least it's isosceles because it's got two congruent sides. Well, now it also has two congruent angles. Where are those angles? Across from the congruent sides. All right, so if I have AB and AC, what are the angles across from them that are congruent? Angle B and angle C. Okay, so you always look across from the congruent sides and you have congruent angles. And the reverse is true as well. The reverse is true. If I give you in a triangle two angles are congruent, the sides across. So if I give you angle B is congruent to angle C in the same triangle, look across, those sides, AB and AC, will be equal. So it works both ways. All right, it works both ways. Before I move on, just I know this is always a mistake that comes up. So let me try to eliminate it now. In an isosceles triangle, it's not always the bottom angles that are equal. I don't want you guys to get in that habit. Let's say I call this triangle DEF, and I'll tell you DF is congruent to EF. Where would my congruent angles be now? Okay, and where would my congruent angles be now up here? 13? What's across from this side? What angle? E would be congruent to what's across from this? D. All right, I just don't want you guys to get in the habit that, hey, it's always the bottom two. It's not. And now do you guys understand what I mean by across from? We're okay? All good. All right, and last thing before I go on to if this thing shuts down. Yep, it's going to. Good job. Just when I was gonna make a good point. Okay, last point. This fact about isosceles triangles only works if the two sides that are equal are in the same triangle. Okay, take a look. They have to be in the same triangle to work. It does not work here. See how I made those congruent? That does not mean that these angles are equal. Do you see what I mean? The angles and the sides have to be in the same exact triangle, not two different ones. Okay, a little common mistake there. But all right. So what do you say? I don't have much. We just went over that one. Okay, vocabulary. Do I always want to say the two congruent sides? No, I don't. Do I want to say the two congruent angles? No. First of all, mark on your diagram where the two congruent angles are for me. That's an isosceles triangle. I marked the sides already. Where are the angles that are congruent? Mark the two angles. What angles did you mark here? Two. What angles did you mark? B and C are congruent. Good. All right. See the non-congruent angle? The one that's not congruent to the other two? Let's start referring to that as the vertex angle. Okay, vertex angle. The two sides in an isosceles triangle that are congruent, legs. So anytime you hear the word legs, that means the two equal sides. And the side that's kind of like the outcast, base. That's the base. Now, just be careful when you use that word because I think everyone associates base with bottom. It's whatever the unequal side is. All right, the base. And then the two angles that are equal, I'm going to have you guys come up with this. What's that side in between them? What did we just call that side in between the two angles that are congruent? So in this case, BC. What did we just call BC? The base. So those two are the Base angles, got it. Yep. So those are the two congruent angles, the base angles. All right, let's see if we can do this. I have a lot of markings on that diagram. You guys see a couple isosceles triangles in that diagram? Let's name a couple isosceles triangles first before we start this one. Name one isosceles triangle in this diagram. 7? RUV, good. So triangle RUV is isosceles because it's got the two hash marks. There's two more isosceles triangles I see in this diagram. Name another isosceles triangle. 6? VWS, yep, the small one over here. Why is that isosceles? It's got two congruent angles. And name one more isosceles triangle for me before we start. 3? It's a big one, right? Good job. So there's 3 isosceles triangles in this diagram. All right, give me another angle that's congruent to angle R. That's not marked. I don't want a marked angle. Give me another angle that's congruent to R. You know R is part of 2 isosceles triangles. R is congruent to what other angle that is not marked, guys? Not marked. Okay, that doesn't have an arc mark. I think you have that angle. 7 thoughts.
Angle V.
Okay. Yep. Good.
UVR.
Good catch, Gary. Get a little bit more specific, right? Angle UVR. Yep. Everyone good? UVR, because it's in this isosceles triangle. What's across from the congruent sides? Congruent angles. Great job. All right, the Y part. The Y. And I'm doing this now because guess we're going to put this Y tomorrow in your reasons column when we start proofs with isosceles triangles. Here's your Y. In a triangle. Maybe not. In a triangle. Congruent angles are across from, and you guys want to finish that? Are across from. I like it. I never heard that one before. Spence, way to go. Never heard that one. You can use are across from legs or congruent sides. In a triangle, congruent angles are across from congruent. Now, hey, take a look. I don't care if you flip-flop them. It's the same theorem. Okay, so if you happen to put congruent sides or across from congruent angles, okay. What's not negotiable with me, what's not negotiable is that beginning part. That's got to be there. Well, why is that got to be there, Mr. Carlino? Because let's say that's a parallelogram. Doesn't work. The angles across aren't equal. Okay, it doesn't work. All right, only in a triangle does this work. So that's why that in a triangle part has to be there. All right, a couple more, and I'm going to let you do a few on your own. RT, side RT. Figure out what isosceles triangle it belongs to. Find the congruent angles and the sides across. And RT would be congruent to what other side up here? 2?
RT, ST.
ST, good. In the big isosceles triangle. And again, this is just practice for tomorrow. Same reason. In a triangle. You can switch them too. How about that? We'll go nuts. Congruent sides are across from congruent angles. And then one more. How about side VW? Look at that isosceles triangle now. VW and 8 WS. Good work. All right, so look for 2 sides or 2 angles in the same triangle, and the sides or angles opposite will be equal. All right, any issues? All right, you can try You know, if you want to work with other people, that's fine. But if you work solo, that's fine too. I'll give you guys about 2-3 minutes to find X and Y in each problem. Find X and Y in each problem. Okay, you guys see isosceles triangles. Give you guys a second to finish up. All right, ready to roll? Here we go. Let's start with angle X. How did we get to angle X? 9. Here we go. Talk to me. How did we get to angle X? We start with 55 here, right?
Yeah.
All right, so where do we go from here?
Other side would be 55.
Good. All right, because, hey, take a look, everyone. We got an isosceles triangle across from congruent sides or congruent angles. Keep going.
And then 55 plus 55 plus x equals x equals 7.
Great job. All right, everyone good? Isosceles triangle. Good job. All right, how do I get up to Y now? 3. How do I get up to Y? Yeah, I don't think you mean linear pair. They add to 180. You're not thinking of the vocabulary term. Begins with V, ends in vertical. Vertical angles, good.
So vertical angle above x is 70.
Yep, vertical angles are congruent. Yep, I'm still listening.
And then I subtracted 70 from 80
Yep,
to get 110.
yep.
And then I divide by 2.
Y divide by 2.
Because I was trying to let it to 180 and you need 2 more angles.
And how'd you know those 2 angles were equal? Because you're dividing by 2.
Because their base angles are equal.
There you go. This triangle's isosceles. Across from the congruent sides are congruent angles. So we ended up with what here, Spence, for Y? Good job. Okay, everyone's good? No issues? All right, how about this bottom one? You can pick what variable you want. You could find Y or X first. It didn't matter. 1. Anna, what are you going to go for, Y or X?
X.
Sure. So how do I start at this 110 and get over there? No? Okay, 110. What's next to it? What do you know about these 2 angles, the 110 and the 1? Okay, so what's got to be the one next to it?
70.
70, good. Now look at the whole triangle right now. What type is it? It's isosceles, right? So what's across from those congruent sides?
The place angles.
Yep. So one of them's already 70. The other one?
70.
Also 70. All right, good. And then how about angle Y now? Angle Y. 11.
40.
How'd you get 40?
Added 70. Wait. Yeah. 40.
Okay, how'd you get 40?
Because I added 70 and I got 1. Then
You added 70 and what?
added 70 and 70.
Okay, you get 140, right?
Yeah.
So you get 40 for
Oh, 20.
that remaining angle. Yep, 20. Everyone's good? We sure? All right, let me go over something right now because I don't want you to skip it when you hit it on the homework because you're going to have plenty of time to do and finish it. So just, you don't have to copy anything down. Okay, here we go. You're going to get something like this coming up. What do I know about 24 and x squared minus 2x? Let's start there. Geometry. 10, what do I know about those two angles? I got, these are hash marks up here.
Oh,
They're congruent because they're across from congruent sides. So x squared minus 2x is equal to 24. Everyone agrees? You're going to see on tonight, I already put it on the bottom of your packet. It says factor. All right, so let me just review right now how you're going to factor these tonight. First thing, you got to make sure one side's equal to what? 0. So I'd move the 24 over how? Subtract it over, good. So equal to 0. Now you're going to try to find, remember, two numbers that do what? Two numbers that multiply to which one up here? 24. Multiply to 24, but add 2? 2. Anybody think of any numbers? Because I don't want you to just to skip this here. This is why I'm going over factoring. Two numbers that multiply to 24 but are 2 apart.
6 and 4.
6 and 4. Now I need to make them add to -2, so what do my signs have to be? Negative and positive. Are we okay here? Am I just wasting my breath here? Because you're going to have to do it twice tonight. One time on 38 and one time on 39. And are we going to be good? Okay, because I'm not interested in the drawings when it comes to the homework. So then I'm going to have x plus 4 equals 0. X minus 6 equals 0. Solve both of them for x. X equals 6. X equals -4. All good? Then what you're going to do is, because remember we rejected an answer in a previous problem a couple weeks ago, you plug in your one answer, see if it gives you a positive or negative angle. If it gives you a positive angle, you accept it. If it gives you a negative angle, you reject it. All right, we good? Okay, let's see you do it then. Grab a book. Let's get going. This is not optional either. Let's grab a book and get going.